Whoa, Crash Course Instrumentation / Episode 46. Title, Beyond the Basics. Real-world DMM tips and troubleshooting logic. You've learned how to measure voltage, current, and resistance. You know your probes, ranges, and continuity checks. Now let's take it further. In this final episode of our multimeter series, we're covering real-world tools, features, and logic that help you troubleshoot faster and more accurately. This is where your multimeter stops being a classroom tool and becomes a field instrument. Phantom voltage, don't chase a ghost. Ever measured 60 volts alternating current on a wire you know is disconnected? That's not bad wiring. It could be phantom voltage. Phantom voltages happen when long wires pick up stray electromagnetic fields, especially in conduit near energized circuits. There's voltage potential, but no ability to source current. Use a meter with low impedance mode, often called low Z, to eliminate phantom readings. This setting loads the circuit slightly and causes phantom voltages to disappear. If your meter doesn't have low Z, try placing a known resistive load across the leads, like a test lamp or even a solenoid coil. Advanced meter features you should know and when to use them. Modern digital multimeters often include functions beyond volts, ohms, and amps. Here are a few to master. Min Max Mode captures the highest and lowest values during a test. Use this when monitoring voltage drops over time, such as during startup or shutdown of equipment. And Hold Function freezes the screen so you can look away or reposition probes, helpful in tight spaces or when documenting a reading. And Relative Mode subtracts a baseline value from the reading, great for checking small differences in temperature, voltage, or resistance. Beck Diode Check sends a known forward bias voltage through a junction, essential for testing diodes and transistors for correct behavior. And Frequency and Duty Cycle, useful when testing pulsed signals, motor drives, or control loops that rely on timing. Capacitance and Temperature Modes, handy in HVAC work, motor start capacitor checks, and thermocouple verification. These tools save time, increase confidence, and often help isolate intermittent faults. Troubleshooting wisdom. Occam's razor. Occam's razor says the simplest explanation is usually the right one. In troubleshooting, that means check the power before checking the processor, check the fuse before blaming the sensor, check the ground before changing a part. Use your multimeter to answer basic yes/no questions. Is there voltage? Is there continuity? Is current flowing? Build from the simplest test outward. The more complicated your theory, the more likely you've missed something basic. Real-world multimeter habits. Professional technicians rely on habits that make their work faster and more accurate. Document every reading, voltage, time, location. Use live dead live to verify your meter before and after use. Trust but verify. Double-check unexpected values. Compare to known good circuits. If something looks strange, use the right probes and test points to avoid false readings. And above all, respect electricity. Don't fear it. Understand what you're measuring. Use the right safety-rated tools. Check your leads and meter settings. Always think before you probe. These habits make the difference between replacing the right part once or swapping the wrong one 3 times. Did you know? Many low-cost digital meters will show phantom voltage in the dozens or even hundreds of volts when reading floating wires. In one documented case, a building maintenance crew wasted hours tracking down what appeared to be a live wire, only to find the circuit had been off for days. A tech finally used a low-Z commercial meter and confirmed the reading vanished under load. Lesson? Always verify before you assume a circuit is energized. Quick recap. Use low Z mode to eliminate phantom voltage. Take advantage of min, max, hold, and relative features with purpose. Use Occam's razor. Start simple. Build troubleshooting habits that save time and prevent mistakes. Respect electricity. Measure with knowledge, not fear. Thanks for watching episode 46 of Crash Course Instrumentation. That wraps up our Multimeters and Measurement Techniques series. Next up, we dive into the world of an overcurrent protection, starting with fuses, breakers, and how circuits defend themselves. Big thanks to Tony Kuphaldt and the open source Model community. Learn more at ebiblio.org. Kuphaldt lar Socratic model. Like, subscribe, and join our Facebook group for more hands-on knowledge every week.